Okay, so you've seen this question before. We've played with this question before. We used it and we created a scatter plot on our calculator that looked like that, and we created a line of best fit. You'll remember all these numbers popped up here. Now, eventually, what we ended up with was an equation that looked like this. We can either say y equals 0.369x plus 1.82. That's pretty much what your calculator spits out. But because this particular question was about distance, remember the question was the following table shows the bus fare charged by a bus company for different distances. So if you travel this far, you pay this much. So what we've done is recreate that formula, but with f and d for the fare and the distance. Now this equation, I can't express how important it is, how useful it is, and how much this sort of calculation gets used in real statistical analysis, real world stuff. So for instance, there's two types of questions you can answer with this. One of them is very, very easy. The other one takes a little bit of algebraic manipulation, I guess. So the first easy one is, how much would it cost to travel 20 kilometers? Okay, so there's our first type of question. Because we have an equation that has fare and distance in it, if we know one of those things, either fare or distance, we can find the other thing. So if I know I'm going to travel 20 kilometers, using this formula, I should be able to figure out how much it would cost. And I can do that by subbing, that means substituting 20 for the letter D, because 20 in this case represents kilometers distance. So when I do that, this formula then becomes f equals 0.369. Now where the letter D was, I'm going to put the number 20 in brackets plus 1.82. Now if you read this part of the equation, it says 0.369 times 20 plus 1.82. Now you can type that directly into your calculator. So I'm going to go back to my regular calculator section. 0.369, open a bracket, 20 plus 1.82. Okay, and I get an answer, 9.20. So the answer to my question, how much would it cost if I travelled 20 kilometres? About, and that word's important, about $9.20. Remember that when we sketched that, if I go back to my stat mode, remember that when we graphed that, what we ended up with was an approximate line of best fit. So we're guessing that it's going to cost about $9.20 if you travel 20 kilometres. It's not exact, but it's a really, really good estimate based upon some solid mathematics. Okay, so that's one thing that you can do with it. You can substitute all sorts of values in there. What if I travel 10 kilometers? What if I travel 8 kilometers, 5 kilometers, 50 kilometers? It starts to break down if you increase it by too much, because if you travel, you don't really travel on Brisbane City Council buses for hundreds of kilometers, so it wouldn't really make sense to extrapolate this out to 50 or 100 kilometers. Okay, the second type of question, which is more difficult, is the reverse of this. How far can I travel for $5? Okay, so this time I know the F value, but I don't know the D value. So I know that the fare is $5, but I want to know how far can I travel with that. We do the same thing though. We know our function, if I can find my pen. We know our function. Our function is f equals 0.369D plus 1.82. Now our next step is to put 5 in where the F is. 5 equals 0.369D plus 1.82. Now this, you might need to think back to year 9 or 10 where you did some algebra and you might really have some trouble with it. The good news for us is that every time we do these kinds of questions, it's going to look the same. 5 equals a number and then a letter plus another number. So follow these steps. The 5 sort of shuffles over a bit here, and this number, 1.82, comes over to this side, and when it does, it becomes negative. 5 minus 1.82 equals 0.369D. And we can do that bit on our calculator. Okay, 5 minus 1.82. Okay, and that gives us 3.18. If I can find my pen again, 3.18 equals 0.369D. And then finally, this last bit, we need to get D by itself, but this 0.369 is here. So every single time you do this kind of question, it'll be 3.18, or whatever that number is, divided by whatever this number is, 0.369. Now, when we're done here, we should have an answer. So we do 3.18 divided by 0.369. Okay, and we get an answer of D equals 8.62. Now again, that's only approximate. So the question I was asked was, how far can I travel for $5? The answer, according to our maths, is for $5 I can travel about, there's that about word again, 8.62 kilometers. Whew. Okay, so just go back, right back to the start. We were given a table of values, distance versus fare, and then we used our calculator in stat mode to put those into the list there. And then we were able to graph it, first by pressing the set button to make sure it was set up correctly, and then graphing it, and we got a graph like that. So that was the first step. We've got a nice scatter plot, everything's very pretty. The next step was to calculate a linear line of best fit. We always use this X. We created a linear line of best fit, and it gave us these numbers, which we then wrote down on our piece of paper here. Now, it'll always be in the form, where's my pen? It'll always be in the form y equals ax plus b, and the a value will go there and the b value will go there. Now, the big payoff was, when we did that, when we put our a and our b value into there, we ended up with this magic formula here and here. Same thing, just y and x and f and d. The f and the d make more sense because we're talking about fares and distance. That was the end of our first video. In this second video, we've made use of that formula. We said, okay, I've got a formula now. F equals 0.369D plus 1.82. Why don't I find out how much it would cost to travel 20 kilometers? And we put 20 into the formula and we got an answer. The other, more complicated version was this one. How far can I travel for $5? And in that case, you have to put a 5 where that F is, and then do a little bit of algebra, and an answer pops out. For $5, you can travel about 8.62 kilometers. Lots and lots to cover. My advice to you guys is practice, practice, practice. Get comfortable with it. Get comfortable with using your calculator. If you don't have one yet, make sure you get onto it and grab one. And ask questions. In class, talk to me, ask questions. Make sure you fully understand what you're doing. And this sooner or later, I'm not going to say it'll become second nature, but it'll certainly become easier as you move along. All right, that's what is it? Using line of best fit for calculations.